example number 4, it says find the 7th term of the arithmetic sequence whose first 2 terms are 7 and 9. Okay, so my first 2 terms are 2 and 9, and they want the 7th term. Now, if they had not told me this was arithmetic, I wouldn't have enough information to go on, because I would need to be able to go through and say like 3rd term minus 2nd and 2nd term minus 1st to make sure I had a constant difference. But because they've told me this is arithmetic, then I can just go through and say, what would my constant difference be? 2nd term minus 1st. 9 minus 2 is going to give me 7. Right, that's going to be my constant difference. Now, there's kind of like a hidden question in this problem. They asked me find the 7th term. If I'm going to find the 7th term, that means I got to plug 7 into the equation, right? So really, that means there's a hidden question here of find the equation for the arithmetic sequence first, and then you can plug the 7th term into it. All right, so let's go through and let's create that equation. We know that if we have an arithmetic sequence, the formula we use is a sub n equals dn plus c, where c is the first term minus the difference. We just found that difference was 7, so we can plug that in, and now we just need c. So what was our first term? 2, and what was our difference? So we can do 2 minus 7, and we'll get our c is negative 5. So now we have an arithmetic sequence formula. So now I could go back and find any term they wanted. They asked me for the 7th term. They could have asked me for the 57th term. It doesn't matter. They asked me for the 7th term, so I could go through and put 7 in the place of n. So if I put 7 in the place of n, put 7 in the place of n, then I'll end up with 44 as my 7th term. Now I know what some of you are thinking. Why should I go through all of that bother if all I have to do to get from the first term to the 2nd term is add 7? I could just keep adding 7, right? So if I add 7 one more time, that'd be 16, and add 7 one more time, and all I'd have to do is just add 7 a few times, and I would be out to my 7th term of 44. You are absolutely right. You could do this problem that way. But then what are you going to do when you get to the problem that it says find the 57th term? You going to sit there and add 7 56 times to come up with it? Probably not my best idea. And what if they ask me for the 507th term? I don't have an option on that one, right? So when it comes to a test or a quiz, am I going to ask you for the 7th term? Not likely. I'm probably going to ask you for something more like the 107th term, so that I know that you're creating the formula and plugging the value into it. Okay? So yes, that would give us another way that we could do this particular problem to kind of check ourselves and see that we were getting it right, but not the best way to do this, particularly if I have higher numbers. All right, yesterday we talked about the difference between a sequence and a series. And we said that a sequence is when you have a list of numbers like 2, 4, 6, 8, 10. A series is if you have the sum of a sequence, where you go back and put plus signs in between instead of commas when you go back and add those values. We also talked about the fact that there are finite sequences in series and there are infinite sequences in series, and we worked with some of that yesterday. Finite just means find the first 5 terms in the sequence or find the sum of the first 5 terms. I have a definite stopping point. It's finite. If they say find the sum to infinity, then that of course is infinite. Or if they're listing all of the even numbers, they're probably going to do something like 2, 4, 6, 8, ... That also would be infinite. So yesterday we mentioned that there are some infinite things that you can find the sum of. They have to be pretty much special cases, and we will see those are geometric in the next section. So what we want to look at in terms of arithmetic sequences and their sums are going to be finite sums. And so they give me the formula for the sum of a finite arithmetic sequence there on the top of page 632, and it's going to be S sub n, so S for sum. N is going to be the number of things that I'm summing, so if they say find the sum of the first 10 numbers or something like that, n would be 10. So n divided by 2 times a sub 1 plus a sub n. Now, when you see a sub n, if they said find the sum of the first 10 things, then this would be a sub 10, right? That would just be the last term, the 10th term in that sequence of terms. So that's all that they're referring to there. So for example number 6, it says find the sum of the integers from 1 to 100. You're having like nightmares of the SAT all over again, right? As soon as you read that question. And what do we do on the SAT? We sit there with our calculator and go 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus, and we get about halfway through and go, I don't have time for this, and we quit. That's not really supposed to be the way we do that problem. There's a handy dandy little formula that we can use. It is the sum of a finite arithmetic sequence, or the sum of an arithmetic series, if you want to think of it that way. So in that case, I would have a formula to find the sum of the first 100 numbers. Where did that formula come from? Well, Carl Friedrich Gauss, when he was, get this, 10 years old, was in school. You know, at that point, probably talking about a one-room schoolhouse with a poor teacher who's trying to teach everything from, you know, kindergarten on up, all in this same setting, and then you have like this mathematics prodigy over here, right? So you can't ever keep him busy, you can't ever keep him occupied, you can't ever keep him challenged. And so one day she's working with him and she was like, Carl, would you please just go back to your seat and find the sum of the numbers from 1 to 100? Now, Carl couldn't break out his handy dandy calculator, right? So he was literally going to have to sit there and go 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, all the way up to 100. That should keep him occupied for a while, right? Not this kid. He came back in just a short period of time to his teacher and said, here you go, and he had the right answer. Let me show you what 10-year-old Gauss did to solve this type of a problem. He said, if I list all the numbers from 1 to 100, I could add the first term and the last term, and that would be a sum of 101. I could add the second term and the next to the last term, and that would have the same sum of 101 because I'm increasing one of them by 1 and decreasing one of them by 1, so the sum stays the same. And that would be the case in every one of these pairs. So all I have to do is say if I have 100 numbers, that's 50 pairs. So that's 50 pairs that have a sum of 101 each, and so my sum would be 5,050. And that is exactly right, and that is exactly what this formula says. If you take your first term plus your last term, that gives you one of the sums of one of the pairs, and then you just need to take the total number that you have and divide it by 2 to figure out how many pairs that you have. So that helps us remember that formula and make sense of it. So let's do that same problem that Gauss did when he was 10. Makes me feel brilliant, right? So let's do that same problem using that sum formula. So we could go through and say, what is n? How many terms are we working with? 100, right. So we could go through and say we need s sub 100. So that's going to be 100 divided by 2. What was my first term? 1. What was my last term? 100. So if I add those, 100 divided by 2 is going to give me 50. And the 1 plus 100, when I add those, I get the sum of each of the pairs, 101. So that gives me my 50 pairs of 101, or my 5,050. That's how I'm supposed to do that problem on the SAT, as opposed to the way we try and do it, right? All right, look at the next one. For the next one, it says, example 7, find the 150th partial sum of the arithmetic sequence, and then they give me the list here. All right, 150th partial sum. That was a bold print term from yesterday. We said that means the sum of the first 150 numbers, okay? So I'm going to go through and I'm going to find the sum of the first 150 numbers. I need to check. They did tell me here that this was an arithmetic sequence, but if they didn't, I would need to check and make sure 16 minus 5 is 11, 27 minus 16 is 11, 38 minus 27 is 11. Yeah, I got a constant difference, so yeah, this is arithmetic. So I can use my arithmetic sum formula. All right, so I come over here. We're finding the 150th partial sum. That means we're finding the sum of the first 150 terms. So let's put 150 in for n, and we'll put 150 in for n. All right, what's our first term? 5. What's our last term? They want a sub n, and n is 150, right? So they want a sub 150, they want the last term. What's the 150th term? I don't know. So here's another one of those problems that it has like a hidden question in it. There's like 2 parts to this problem. I'm going to have to go figure out what the 150th term is before I can plug it into that sum formula. Well, that's okay. We have a formula for finding the nth term, in this case the 150th, the nth term of an arithmetic sequence. That's that a sub n equals dn plus c thing, right? So we could go through then. We've already established that this is arithmetic and that our constant difference is 11. So let's put that 11 in. What was n? Right, 150. And then we can go through and say that c is our first term minus our difference. So what was our first term? 5. What was our difference? So what's c? Right, 5 minus 11 is going to give us negative 6. So if we do 11 times 150 minus 6, we'll get 1,644. That is our 150th term. So now I know what that last term is. That guy right there, that 150th term, that's 1,644. That's my last term. So I can bring it over here and plug it into my formula. Now I can finish that off. 1644 plus 5 is going to give me 1649. And then 150 divided by 2 is 75. So I can multiply those. And that would be the sum of the first 150 terms.